Hello, I Anand Jain from Hanumangarh, Rajasthan welcomes you to your favorite Shridevi Classes YouTube channel where we inculcate interest and confidence in science and engineering subject. Today in our playlist Basic Electrical Engineering and Class 12th Physics in chapter Alternating Current Circuit, we will study one very important parameter of alternating current, form factor, which relate RMS value of alternating signal to average value of alternating signal, and we will understand how a sharp peaked wave would have higher value of form factor and a flat topped signal have lower value of form factor. We will also discuss form factor of some important periodic function. So let's start study of form factor of alternating current. In this figure here, we have shown you three symmetrical alternating current signals. One is standard sinusoidal signal, which starts with instantaneous value 0 at t equal to 0 and would have non-linear increase in positive direction, and after attaining peak it reduced to 0, and then just like positive half cycle, negative half cycle is covered. The second picture show a alternating current with a sharp peak value, and the third alternating signal have a flat topped trajectory. Now all three alternating signals are symmetrical. They have identical positive half and negative half. So full cycle average value of all three is 0. Also they have identical positive half cycle average value. The average value of positive half for this standard sinusoidal signal, this sharp peaked wave or this flat topped wave, the positive half cycle average value of all three is also the same. But if we consider the RMS value or effective value, which is a root mean of square instantaneous value, the square value of this sharp peaked function at peak positions become quite higher than flat topped. So we'll find that RMS value of sharp peaked alternating signal is higher and RMS value of this flat topped signal is lower. So for same average value, these three alternating signal will have different value of RMS value or effective value. The RMS value of sharp peaked signal is higher than other two, and RMS value of this flat topped signal is least among these three. The shape and nature of alternating periodic signal is defined by a parameter known as form factor, and form factor is defined as a ratio of RMS value of alternating signal to average value of alternating signal. So ratio of RMS value and average value is known as form factor, and this form factor define the shape or nature of variation in alternating time varying function. For a standard sinusoidal signal, the RMS value is 1 by root 2 times of peak amplitude, and average value is 2 times Im divided by pi. And when the ratio of RMS and average is calculated, it comes as pi upon 2 root 2. Pi is roughly 3.14 and 2 root 2 is roughly 2.828, and this ratio pi upon 2 root 2 is also 1.11. So form factor of this standard sinusoidal signal is 1.11, whereas form factor of this sharp peaked alteration would be higher than 1.11, and for this flat topped signal it would be less than 1.11. Apart from standard sinusoidal alternating current, during our study we come across several periodic waves. They may be alternating waves such as square, triangular or sawtooth, or they may be a rectified output, half wave rectified output or full wave rectified output. For all these waves we have to find out their respective average value and RMS values. So if we see square wave, all through positive half cycle its instantaneous magnitude always remains the same, equal to its peak magnitude or amplitude. So its average value for positive half cycle is Im, whereas for triangular or sawtooth wave, instantaneous magnitude linearly changes from 0 to peak value and average value is half of peak value. For rectified output, average value is obtained for one cycle, and positive half of standard sinusoidal signal is basically become the cycle for full wave rectified output, and for this average value is 2 times peak value divided by pi, it is 2 Im by pi. And for half wave rectified output for full cycle, the average value is half of full wave rectified output. So for half wave rectified output, average value is Im by pi. And if we see the RMS value of these waves, then for square, since magnitude is constant as Im, so its RMS value is Im. For standard sinusoidal signal and full wave rectified output, it is Im by root 2. For triangular or sawtooth, it is Im by root 3, and for half wave rectified output, it is Im by 2 or Im by root 4. So we can remember this is Im by root 1, this is Im by root 2, this is Im by root 3, this is Im by root 4. So Im by root 1 is for square, Im by root 2 is for standard sinusoidal signal or full wave rectified output, Im by root 3 is for sawtooth or triangular wave, and Im by root 4 or Im by 2 is for half wave rectified output. For all periodic waves, standard sinusoidal signal or full wave rectified output or triangular or sawtooth wave or half wave rectified output, the respective RMS value is greater than respective average value. And if we take ratio of RMS to average, we will get form factor greater than 1. It is pi upon 2 root 2 or 1.11 for standard sinusoidal signal or full wave rectified output. It is 2 by root 3 for triangular or sawtooth wave, and it is pi by 2 or 1.57 for half wave rectified output. But for square wave, its peak amplitude, RMS value, average value, all are Im. So its form factor is 1. So this is the least value of form factor for square wave, which is 1. But for all other waves, since RMS value is higher than average value, form factor is always greater than 1. Certainly, the shape of periodic wave have a relation with form factor. Here in these three waveform, standard sinusoidal signal, sharp peaked periodic wave and flat topped periodic wave, the positive half cycle average value is the same, but RMS value of sharp peaked wave is higher and flat topped wave got least value of RMS magnitude among these three. So form factor for sharp peaked value is higher, that represent that for the same average value it got higher value of RMS value, and flat topped wave got lower value of form factor. It means for same average value it got lower value of RMS value. Now form factor also become very important to decide average current rating of thyristor in controlled rectification application. And when we change duty cycle, the form factor of our device will change. And if we got a higher value of form factor, then for same temperature rise conditions, we have to derate the current rating of thyristor for safe operation. We hope this beautiful learning video has explained each and every aspect of form factor in alternating current. Now you understand form factor is ratio of RMS value to average value, and for standard sinusoidal alternating current, its value is pi upon 2 root 2 or 1.11. Now we understand form factor of other popular periodic waves, and we also got an idea that for sharp peaked wave form factor got higher value, and for flat topped wave we got lower value of form factor. And when form factor is higher in a thyristor circuitry output, we have to derate average current rating of thyristor, because heating are produced by RMS value and we are having output in terms of average value. And if duty cycle is such that form factor is higher, it means for same average current we are producing more heating to the device, so we have to reduce current rating of such thyristor. Our other learning video of the same playlist are equally useful, and if you need dedicated exams and trick notes or online doubt clearing classes from this channel, do join our YouTube membership. Happy learning, have a nice time. Thank you very much.